Okay, so it's a simple sonar sensor tutorial. So we will see that when I take my hand near, the LED is bright, and if I go far, the LED is dimmer. And in this video we will uh, help this datasheet, and we will show you step by step how this code actually works. A lots of comments here. Actually this is my research, but I will show you this thing easily. And I have provided the datasheet link here, and I will provide this code in the description. Okay, so let's start. So first of all, let's come here. Let's do this thing step by step. So this is trigger 7 equals. So what does this mean? Let's see. So let's say we have an Arduino. So first of all, we have to power up this sonar sensor. That means we have to take positive 5-volt pin and connect it to the VCC pin of the sonar sensor, and similarly take the ground pin and connect it to the sonar sensor's ground, and in this way you have powered up the sonar sensor. Okay, so next, how the sonar sensor is working. So first of all, sonar sensor has two things. One is transmitter and another is receiver. You see, one is transmitter and another is receiver. So here, so actually this is the transmitter and this side is receiver. You can see okay, so how this actually works. So this transmitter, if you put a positive voltage here, if let's say you input a pulse here, let's say this kind of pulse, and according to the data sheet, this pulse width should be recommended, this pulse width should be 10 microsecond. So you have to apply a pulse here at the trigger pin of the sonar sensor, and if we apply this thing, it will send a ultrasonic wave which is 40 kilohertz, and it will transmit 8 cycle. That means 1 2 3 4 5 6 7 8. So it will transmit 8 cycle 40 kilohertz ultrasonic sound wave, and it will propagate here. If you have an object here, let's say this is an object, my hand or anything, then this wave will be reflected and received by the receiver. And if there is no object, then receiver will don't have any ultrasonic wave, and we will show you how this receiver receive this thing. Okay, so first let's see what this code actually doing. So we have defined a variable trig and echo, and you see the trig pin is 7 and echo pin is 6. That means we have to take the Arduino 7 pin and connect it to the trigger, and take 6 number pin and connect it to the echo. Okay, then speed is 3. This is actually air speed 350. We will talk about it later, and we will also talk about this LED element later. Okay, so first let's work with the sonar sensor. Okay, so setup. So first of all, we have to put this trig pin as output mode and echo pin as input mode. Why? Because we are applying a pulse. And this pulse will be from Arduino. This pulse is from Arduino, and that's why Arduino is giving this pulse as output, and that's why we have put this trigger pin as output, and echo should be in input. Now it's the time how this echo actually works. So echo, basically how this echo pin actually works. So when this signal, let's say this transmitter, when let's say this is a trigger pin, this transmitter, this is let's say echo pin, and this is let's say receiver, and when you apply a pulse here, so I have told you that this transmitter transmits a ultrasonic sound wave which frequency is 40 kilohertz, but if let's say assume that, and at the same time after transmitting this wave, this echo pulse was initially this echo pulse was low, but now this echo pulse becomes high. Okay, so now this echo pulse becomes high, and it will remains high until this receiver receives any wave. So let's say here is an object, and if this wave reflected and received by the receiver, then again this echo pin will be low. So we have a pulse in function. We can know that how much time this echo pin was high. Let me tell you again. I think I was not able to make it understand. So okay, so when this transmitter will transmit a 8 cycle 40 kilohertz wave, this echo pin was initially low, but after this burst, after the transmitter transmits this, it will become high, and it will remains high until the receiver receives any wave. And when this receiver receives a wave, you can see that this echo pin will again become low. That means the total time is t. Actually, let's say this time is t, and this time is also t. I mean the wave bouncing here, then again back to here. This time is also t. So that means if we somehow find the time for which this echo pin is at the high position or positive 5 volt position, we can understand the traveling time of this wave. And then if I somehow find the time, we can apply the formula 2d is equal to bt, or d is equal to vt by 2 to find the distance, where d is the distance from the sonar sensor to the object. Okay, so let me dive into the code. So, and that's why you see this trigger pin has been output and echo pin is input, because we have to take the input from the echo pin and to find out the time. And let's talk about this LED later. Serial.begin 9600 is the baud rate this to operate this serial monitor actually. Okay, now you see digitalWrite. Initially we set this trigger pin low. Initially it's formality, just avoid this line. It's just, let's say, formality to you know that we are creating a pulse, right? So how to create pulse? First we should have low, and then high, and then again low, right? So first let's make this trigger pin low. Well, so this trigger pin is low, and then you see after 2 microseconds you have made this trigger pin high. So this trigger pin is now at the high position, and this delay 10 microsecond is recommended by the datasheet. If you see that datasheet, you can understand there is written that we have to take this 10 microsecond, and then we have to again make this low. Okay, and if you do this thing, there is a monostable circuit inside the sonar sensor which detects the rising time. This is actually rising is. So that sonar sensor detects the rising is, and if the sonar sensor detects this rising is, it will transmit a 40 kilohertz 8 cycle ultrasonic sound wave. Okay, so now you see you have used a pulse in function. Why you have used this pulse in function? Let's try to understand. When you transmit this ultrasonic sound wave at the same time, or after emitting this sound wave, immediately this echo pin goes to high, and it remains high until you get any wave back to the receiver. And by this pulsing function you are actually find this is actually echo pin, and you are finding how much time this echo pin is high. You see, echo high. So this you are trying to find actually how much time this echo pin is at the high position, and you will get this time in microsecond unit, because this pulse in function actually returns the time in microsecond units. And what is this big number? This is actually 30, actually it is 300,000 microsecond or 300 millisecond. Actually this it's actually okay, let me tell you here. So you know that this code is operated step by step, right? First this code will operate this code, then this code, and then this code. And you see this code will stuck here. Actually this code will stuck here because why this code will stuck here? Because initially this is echo pin, echo was low. So after you transmit the signal, echo becomes high, and then it will remains high until any wave is received. And if any wave is not received, this your code will stuck here, and we don't want this code stuck here. We want to progress because we have a lot of codes below, and that's why we use this number. It's actually 300,000 microsecond, or actually 300 millisecond. That means this code will stuck here, or this pulse-in function will wait for 30 millisecond, and after 30 millisecond, if you don't get any wave reflected, if there is no object, it is obvious that no wave will be reflected. And if no wave is reflected, then this pulse-in function will no longer wait and progress to the this lines. Okay, so I think I have told you a lot of things. So now let's move here. Now this is actually where the time is in microsecond time. We are actually printing the time. And then float L, this is actually L. So what is this actually? You know that sonar sensor looks like this. Here you have a transmitter, and here you have receiver, right? And let's say the object is actually here. So transmitter will transmit, so the transmitter will transmit, and then it will receive, right? So this total distance is actually L. That means this is L by 2 and this is L by 2. So the total distance no, actually this is L and this is L, and the total distance is L by 2. So okay, so 2L is equal to simply Vt, right? Where T is equal actually time and V is actually speed. So our speed is 3500 meter per second, and time is obtained. Okay, so here we can get L is equal to 0.5, then speed, then time. But you can see that we have additionally divided by 10,000. And why we have to do this? Because we want this L in centimeter. We want this L in centimeter, but the speed is in meter per second, and this time is in microsecond, but we want this in centimeter. That's why we have to make this meter per second into centimeter per second, and that's why we have multiply it by 100. That's why we have multiply it by 100, and then this time is in microsecond, but we want in second, and that's why we have to divide it by 10 to the power 6, and that's why this is actually 1 by 10000, and that's why we have divided by 10,000. Okay, so whatever we have found L. So this is actually L. Now what is actually X? This X is the distance between transmitter and receiver. That means this is actually X, and I have measured it by scale normally. And so how can I find the distance? So actually this is the distance. So using a Pythagoras formula you can easily find it. Sorry, actually this is x and this is x, so the total is actually 2x. So if we want to find the distance, so distance is basically use Pythagoras formula in this triangle, so L square minus x square. So use this here where we can write it, distance is equal to L square minus x square to the power half, and you see we have a L square plus x square to the power half, and then we have find the distance. Okay, so I think sonar sensor, the part of sonar sensor has been done. Now how to control the light intensity, that if the sonar sensor and the object is far, then the LED is dimmer, but if sonar sensor and object is near, then you can see that the LED is bright. And why this thing actually? Because, and how I'm actually doing this, because from Arduino we only get 0 volt and 5 volt. If you want 3.3 volt, it's not possible. If you want 2 volt from the Arduino, that's not possible. So how you are actually controlling the LED brightness? Well, so I am actually doing this by PWM signal. Okay, so how I am actually doing this, you know that I'm actually giving PWM signal. I'm actually giving a PWM signal. So do you know what is PWM signal? Let's say it's simply a square wave. It's 0 volt to 5 volt, and this is the time period, and let's say this is the time TD for which the square wave is at the high position. So duty cycle is actually TD by T. Okay, so if duty cycle is 255, that means the LED is always, this square wave is always 1. But if this duty cycle is 0, then it is always off. So I think you get the idea. If the duty cycle is 125 or 128, I mean the medium of 255 divided by 2, then the duty cycle is 50%. I mean 50% time it's on and 50% time it's on. Okay, I think you get the idea. Okay, so how I'm doing this. Okay, so we have to take a, sorry, it's actually 0. Okay, so how I am doing this, first let's define the intensity and map it. So how to map it? So let's say our distance, so take the distance. This distance might be anything. Let's say you have find that the distance between sonar sensor and the object is, let's say 20 centimeter. It might be anything, we don't know what is this, it will change, it's variable. But you said that if distance is 0, you see a distance is 0, then the duty cycle, or that duty cycle is represented by intensity in our code. So you see the intensity variable here. So when the distance is 0, the duty cycle is 255. That means 100% time it's on position. You see 0 255. And when the distance is 30, you see that when the distance is 30, you have set the duty cycle to 0. That means the duty cycle, you have set the intensity to 0. That means 0% time this square wave will be on. That means if the distance is, let's say 20 centimeter, then you will get the intensity between 0 to 255. Let's say the distance is 15 centimeter. If the distance is 50 centimeter, then by using this map function you will get the intensity. You will get the intensity is 255 divided by 2. That means the intensity duty cycle is 50%. That means the square wave will be 50% on and 50% off. Now let's talk about the psychology. Let's say this let's say the square wave is all the time on. That means this LED, you will see the LED bright. But if you apply a square wave here, so sometimes LED is bright, sometimes LED is bright, and sometimes LED is dark. But here is the point. You know that we have a limitation in our eye, in our brain, that's 0.1 second, right? It's the limitation. Between this 0.1 second, if there is any change, we can detect it. So that's why if you if you were a robot, then you can detect that the LED is on, then off, then on and off. But we are human, so we will see that the LED is getting is glowing in lower brightness, and if you decrease the duty cycle, I mean the time for which LED is on, you will see that the brightness is very low. And this is actually the psychology. This is actually how our brain works actually. So actually if you were a robot, you will see this LED is on, off, on, off, on, off, on, off. But actually we see that the LED is we actually perceive it. It's kind of illusion, right? Okay, so you see, after this function constraint, if sometimes this intensity is beyond 0 to 255, this constraint will forcefully take it between 0 to 255. Let's say this is 0, this is 255, but by using this intensity you obtain 300. But no, intensity should not be 300, it should be 255. And if it is, let's say, 128, so it's not there is no problem, constraint function will not work. But if, let's say, just an example is -1, there's no intensity will be that's times 0. That means this constraint function is always taking intensity between 0 to 255. Okay, so then you have okay, so let's go here. So you see you have a LED pin here which is 11. That means you are taking, this is actually Arduino take 11 number pin, and we have a ground pin here. So you see this LED pin is 11. That means you take a resistor of 1K, then connect an LED. The taller part should be connected here. You see that you have a taller part on the LED. This is actually LED, one part is taller and one part is shorter. This taller part is called anode and the shorter part is called cathode. And this is actually the taller part, this is actually the shorter part. So you have to connect it to the ground. Okay, and then as you are glowing this LED, you are passing a square wave to the LED. So LED should be in output mode. Oh, one thing you will see, if you see in the Arduino, you will see that at the 11 number pin, let me see, yes, at the 11 number pin you have this kind of symbol. You have this kind of symbol in 10, then 9, then 6, then 5. If you have Arduino in front of you, you will see that some of the pins have this kind of symbol. These are actually PWM symbol. That means this signal supports PWM. That means this signal actually supports this kind of square wave. But if you don't see any symbol, let's say 13, you will see that 13 has don't have this kind of symbol. That means 13 is can't give you any square wave, it will give only 5 volt, or if it will give only 0 volt. Okay, so you have to connect it to the PWM pin. And now let's go to the LED part. So you see the LED driving. So we have used this analog write, so we want to conduct this LED, and you see this is intensity. So what happens actually, analog write, so this is LED actually 11. So 11 pin will now give output, and we have put here intensity, you see. So if intensity is, let's say, 255, then the LED is on for 100%, and if LED is, let's say, 255 divided by 2, it is actually on for 50%. Okay, so now I think I have done yet. Now let's go to the datasheet. So this is actually datasheet, and one more some things I should tell you that okay, so one thing I should tell you that here it's recommended that we should connect a 1 kilo ohm resistor. That means it's recommending you where here, so it's recommending you to connect here a resistor of 1k, sorry, not here, actually here. So connect a 1k resistor between echo and 6, because you are actually taking the a positive 5 volt. This echo is actually giving you a positive 5 volt to the Arduino. So it's a good practice to connect a 1k resistor here. And one thing, and another thing, if it's not Arduino, let's say it's an ESP32, let's say you are working with ESP32, and you know that ESP32 can handle 3.3 volt, right? But you know that this sonar sensor echo pin is giving you actually positive 5 volt. So if you apply positive 5 volt here, you know what happens, this pin will damage. And that's why you have many ways. One way is to apply a voltage divider here. So let's say, so this is a voltage divider 1k, and if you take the output from here, you will see this is actually 3.33 volt. So this is one way to work with ESP32. You can use a voltage divider here. But for Arduino, as Arduino can handle 5 volt, so just apply a resistor of 1k. It's actually current limiting, it will limit the current actually. Okay, then another thing is here, you see, I have told you previously that 10 microsecond is recommended, and it's actually passing each cycle of sonar sensor, and then this echo pins will become high and wait until the echo pins becomes low. And some of this here, let's say you see the sonar sensor should be powered up by positive 5 volt and quotient current. So what is quotient current? Let's say when the sonar sensor is not working, just sitting idle, and that time it will take 2 milliampere current. That means at the idling time the power dissipation is not 0, you have to supply some power, and working current is 50 milliampere. That means when sonar sensor is working, it's actually 50 milliampere. Then the effective angle, that means the object, okay, then ranging distance, you see 2 to 40 centimeter, resolution, and many other things has been, you see the trigger input pulse width 10 microsecond is recommended here. Okay, And let's see, is there any other thing here? Distance formula has been used, this formula has been used, but we have made a triangle for some accurate result. And is there any other thing? You can read this datasheet. It's a good practice to read the datasheet, not to just watching YouTube videos, or it's a good practice. You can go to the datasheet.com and you see recent. I see that they have a chat AI. You can chat with AI with about this datasheet also. Okay, so I think that's all for today. I think this video is actually so boring, but yes, I know this video should be boring, but whatever. I was trying to tell all the thing, and that's why I have made this video boring, because good thing is always boring. Okay, so thank you.